Hi everyone. We're really excited to welcome you to the first cohort of the Marlowe Pioneer Program. So the course will feature several Marlowe team members, some old faces and some new. Myself, I'm Umar Hussein. I'm the product manager for Marlowe. And today I'll be joined by Simon Thompson and Pablo Lamela. Lars, Brian, Eve, Oliver, and myself will feature again in the course for some later sessions. So let's just talk about a general overview of expectations of this course. What you're basically going to learn is how to write, simulate, analyze financial smart contracts in the blockchain with the use of Marlowe, JavaScript, and Haskell. We're also going to talk a little bit about the real-world application of the technology. So let's talk a little bit about the lesson structure. This week's session is basically an introduction to Marlowe. And Marlowe in a nutshell. So we're just going to give you some high-level idea of what Marlowe is like. I'll just get into that in a second. Next week's session will be about using Marlowe. So putting Marlowe contracts online, running a contract, talking a little bit about MarloweRun. The third week's session is Marlowe in depth. So it's about representing Marlowe, a bit about Blockly, and sort of a primer on analysis and simulation. The fourth week, we'll get into how Marlowe is embedded in JavaScript and Haskell. The fifth week, we'll talk about Marlowe and standards, so how standardization can work in Marlowe, and primarily about Actus at the moment. Week 6 session, we'll get into the assurances and conveniences of Marlowe, so basically about the distinctiveness of Marlowe as a DSL, as a domain-specific language. Week 7 will really be about the Marlowe CLI, so the command line tool, and the expert usage of these tools to either simulate or run Marlowe contracts at the command line. Week 8 will be the mock incubator session. And think of this as an imagination session and an opportunity to explore some very unique use cases within the bounds of the Marlowe requirements. So this will also be published, so no worries about taking notes. Each session will have a series of exercises and live Q&A sessions. So this week is just getting the ball rolling. So we'll be covering some basics, right? Simon will come in and cover the basics on smart contracts, talk a little bit about blockchain and the technical scope of Marlowe. So without further ado, let's pass the ball to Simon.
Hello, I'm Simon Thompson. I work as Technical Project Director for the DApp platform at IOG, but in the past I was head of the Marlowe team, and indeed with Pablo Lamela, we invented Marlowe. Let's talk a little bit about blockchain and smart contracts in general. A blockchain is an irrefutable record of transactions involving some sort of token or cryptocurrency. The reason we can think of these things as like a currency is because we can see each transaction as recording transfer of some unit of that currency from one person to another. So it's like having a big ledger in which you write where every coin, every note has gone. Where do smart contracts come into this? Well, in the simplest case, what's happening on a blockchain is that each transaction records a single transfer of an asset. And that is done, as it were, by hand. Somebody wants to make a transfer, that transfer is then made. But you can imagine automating some of these processes by computer programs, by algorithms. And this is what a smart contract is. It's not smart. Computer programs aren't smart. They do what they're told, and only what they're told. And in a sense, they're not really contracts. They're programs that run on this blockchain. In the Cardano world, we have Plutus, which is the general purpose language for writing smart contracts. So you can write any kind of contract you like using Plutus. It will allow you to have multiple participants. It will allow you to do anything that your imagination will allow you to do. But a problem with that can be that you're not able to predict how a particular Plutus contract will behave. So because of its power, you have greater risk. And that's where Marlowe comes in. Now, one of the things that people try and do when they write smart contracts is to mimic, imitate, replace processes that go on in the real world. Now, that can be complicated because what happens in the real world is that real assets get transferred and so on. If everything is digital, then that can all be done on blockchain. And that can be done in what's called a disintermediated way on something like Cardano, where there is no trusted third party, except of course the blockchain itself, taking part in any financial transactions between a number of parties. But suppose you want to involve something from the real world. Suppose I want to sell you a dog, and somehow we want to perform that contract on blockchain. How could we do that? I could at some point give you the dog, but maybe you won't transfer the money to me, and I've lost out. Or maybe you will transfer money to me, I won't give you the dog. If we don't trust each other, we can't see how we can proceed in that situation. What we can do, however, is we may not trust each other, but we may have a trusted third party, say our friend Carol. And what we can do is perform the actions of this contract on chain. You can transfer the money to me. I can off chain give you the dog, and Carol can agree with us that what has happened, and so we can agree to, if the money is put in escrow into the contract, Carol can then either give the money to you or give it back to me, depending on whether or not the dog has been transferred or not. So we're able, with some trust external to blockchain, to conduct contracts where assets in the real world are transferred. So let's just focus in a bit about what smart contracts do. As I've said, what happens, as we all know, what happens on a blockchain is that transactions are placed on that chain as a record of movement of assets. There are transactions take unspent transaction outputs and spend them, transferring their ownership potentially to other people. So this is how assets flow on the Cardano blockchain. How does a smart contract work? Well, we have to ensure that we make some stipulations about what's to happen, and that is enacted by submitting transactions to the blockchain. That's how the contract takes place. But those transactions don't come out of thin air. So on the blockchain, those transactions are submitted and checked to see that they conform to the contract, but also we have to, off the blockchain, somehow create the right transactions to be submitted and checked. So these programs, these contracts that run, have one part on-chain, one part off-chain. And as you look into the technicalities, this begins to look quite complex, quite subtle, and certainly not a space for a beginner. So how can we try and make that more accessible to someone who just wants to start building some simple contracts on Cardano? The answer is, what we do is step back and say, what is it precisely we're trying to do with these smart contracts? What we said with Plutus is that we would try and build a language that would allow us to write any kind of smart contract. But perhaps we could do something different. Perhaps we could say, let's, instead of trying to solve every problem, solve problems in a particular area, a particular domain. Let's build what's called a domain-specific language. That is a language that's designed to fit with the language and the ideas and the concepts of something in the world, rather than being written in the language and concepts of the computer. We don't want to talk about variables and functions and so on. We want to talk about flows of cash. And what we decided to do with Marlowe, inspired by discussions with Charles Hoskinson, who founded IOG, is to look at designing a domain-specific language for traditional financial contracts. So RealFi, if you like. So what we want to do is look at how we can take traditional financial contracts and write them on Cardano. That means we have a much simpler language. We're not trying to solve every kind of problem, with nothing to do with NFTs, for example. But we have a language where we can express, in terms that are understandable to people who work in finance, contracts that can be run on the blockchain. And the advantage of having a more restricted language, a domain-specific language, is that we can design certain guarantees in by design. So we can make sure that the language will not allow certain kind of bad things to happen, or will make sure that certain good things always do happen. So a DSL can give us guarantees that we know whatever program you write, whatever contract you write in that language, it will have certain good properties. And in particular, what we were aiming for in designing Marlowe was to ensure that contracts would always proceed. A contract could never get stuck. You couldn't finish up with somebody being able to walk away from a contract. As you can imagine, if you and I were enacting a contract, I could make a payment into the contract, waiting for you to make a corresponding payment. You could walk away, and potentially that money of mine could sit in the contract forever. We have to design against that kind of walk-away behavior. We have to also make sure that contracts won't go on forever. We designed Marlowe so that we could be sure that contracts would only live a particular length of time, which you can read off from the contract. And we also designed it so that up front we knew who the parties to the contract were. But if you think about it, these are things that are all properties of real-world financial contracts. And what we wanted to do was mirror those properties in the language so that we were able to give those guarantees to anyone writing a program in Marlowe. So as I say, there are disadvantages, there are restrictions, but those restrictions give us advantages in that we can give you guarantees about what a Marlowe program will do. And there are also other things that we can do. Because Marlowe is limited, we're able to guarantee the properties I talked about, but we're also able to check other kinds of properties. So for example, because Marlowe contracts are essentially finite, they don't go on forever, we're able, without running a contract, to check every possible way that contract could evolve. And so we can check in advance to see that any payment the contract might want to make, anytime a contract talks about making a payment, that payment will be executed in full. No payment can fail. We can do that through what's called static analysis. There are also ways that we can use formal verification, machine-checked proof to guarantee other properties of Marlowe and how it's implemented. And those are things we're going to talk about in week 6. Okay, what is Marlowe? What can you do in Marlowe? Well, you can do a number of things. You can pay money into a contract. When I say money here, I mean a crypto asset of some sort. You can pay money out from a contract. So Marlowe can control flows of money, assets, between participants. What else does a contract do apart from have flows of assets between participants? Another crucial thing that can happen is that it can take input from the outside world, as it were. That one of the participants can be asked to make a choice about how the contract should proceed. So there is that kind of choice, and so the contract can go down different alternative paths. And that choice, while it can come from a participant, could also come from a third party. We could get information from an oracle. So, for example, we're able to take information about real-world financial exchange information, for example, and feed that into a running Marlowe contract. So Marlowe allows flows to take place, and those flows can depend on choices by participants and real-world data that comes from an oracle, an on-chain oracle. we're also, as time goes on, we're looking at transferring roles in Marlowe contracts. So when a Marlowe contract is running, just like if you're taking part in a financial instrument, in principle, you can transfer your ownership of that instrument to somebody else. We can do that by specially minted tokens in Marlowe. How do we design Marlowe in such a way that we can give the guarantees I've talked about? I've talked about ensuring that contracts don't go on forever. I've talked about how ensuring that contracts it's not possible for somebody to walk away and not interact with the contract and leave cash locked up. The answer is the contract can't reach out and take money, for example, from your wallet. The contract can't force money to be extracted, and this is a crucial point of the way that these contracts work on the UTXO model. For money to be put into a contract, you have to authorize the money coming from your wallet and going into the contract. So what happens if you don't make that authorization? Well, the answer is that the Marlowe program will have built into it a timeout. So when it asks you to authorize a transaction, it will give you a timeout. And if you don't authorize a transaction by the point of timeout, some remediating action will take place. And so therefore, at the timeout point, progress happens. The contract can't get stuck. And because of the finite nature of Marlowe, we know that there will only be however you execute the contract, there'll only be a finite number of these timeouts. And so once all those timeouts have been passed, the contract will end. And so this ensures that the contract will only go on for the period of time that we can predict. And at that point, the contracts are designed. Any money that's locked in the Marlowe contract will be returned to its owners. Inside the Marlowe contract, we have local accounts, like the account model on Ethereum. But these accounts are local, they only belong inside the contract, and they are closed when the contract is terminated, and the money in each account is returned to its owner. So by design, because of timeouts, we have a finite nature of the contracts, and by design, at the end of that period, we can be sure that we will have all the money returned to the account holders as required.
So, hi again. This time we're going to talk a little bit about why Marlowe. So its mission, the narrative of Marlowe, which is basically, Marlowe is first and foremost a domain-specific language that makes it really easy to write and implement financial smart contracts. What this does is it creates a blockchain-specific way to replicate key financial service processes by making smart contract development really easy. Now, we have a suite of developer and user-facing products that highlight the potential of Marlowe. So currently we have the Playground, which is a tool for developers to write, simulate, end-to-end financial smart contracts with ease in a choice of programming languages, including a visual tool. The second is MarloweRun, which is a tool for end users to execute and visualize their financial agreements using off-the-shelf templates for peer-to-peer loans, escrows, and swaps. This is complete by step-to-step walkthroughs and explainers. So let's get into a little bit about what problems Marlowe is solving. So one of the things we see in the ecosystem at large is that low-code solutions for building smart contracts just aren't good enough. They're expensive, they're complex, and often time-consuming. So Marlowe addresses this in many ways, as you'll see during this course. The second problem is there's a great difficulty in showing complex real-world use cases of smart contracts. These processes that we're trying to replicate are usually so complex in themselves that they can't be easily mapped to smart contracts, let alone prototyped and demoed for getting buy-in with the respective businesses. So the next problem is that we see that various parts of Cardano are not yet fully or well integrated. So that's like wallets, light wallets, identity, metadata exchange protocols, and we want to provide or pave one route to that with Marlowe. The next part is we think financial innovation is happening in three parallel spaces, that of TradFi, DeFi, and the ever nascent RealFi. And this is really the kernel of our ecosystem approach. The problem here is that since they're operating in parallel, the best practices cannot be shared, progress is slow, and each industry finds it very hard to learn from each other, let alone can express their desire in a clear and coherent way. So we want to do two things with Marlowe. We want to proliferate new ways of thinking and application within these worlds. So within DeFi, within TradFi, and within RealFi. But we also want to make it easier to import and export ideas and best practices between these worlds, because I think that's where we imagine the most progress comes from. So we're currently also working on a blog post that elaborates on this vision for a growing ecosystem, and hope we manage to finish that during the course of the Pioneer program, so you have a good outlook of it. And the last thing I'd like to talk about with regards to this is the real world application of Marlowe itself, which is probably something that excites a lot of the team the most. So in week 8, we'll be looking at this mock incubator sort of style workshop. And think of this as an opportunity, as a head start basically into pragmatically thinking about business ideas, pain points, and solutions in the context of Marlowe and understanding its wide range of utility. So we know that Marlowe can be used for smart contracts, templates, it can introduce standards, formula verification, etc. So we'd like for you to take this opportunity to test Marlowe's flexibility beyond the obvious. So really go through with different use cases, and we'll be publishing some details about that in the coming weeks. And this is basically going to be a session which will be worked on iteratively throughout the course, and we'll deal with some of the formalities in session 8 itself. Now I'll pass the ball to Pablo, who will talk about the technical overview of the product suite. Thank you, and see you again in the Q&A.
Thank you, Omer. A lot of work has gone into Marlowe and the tools that surround Marlowe, and we are very excited to share the latest achievements with you. For example, the team has recently successfully run the first Marlowe contract on mainnet, and of course there are limitations, and there's still some way before we can see Marlowe running in day-to-day transactions, but that's why this is called Marlowe Pioneers, because you will be the first ones in trying the system before anyone else does. And for the same reason, we have put a lot of effort into making the experience as smooth as possible. But of course, there will probably be some rough edges, and we will appreciate if you let us know what those edges are so that we can improve. Also, we would like to hear what you think is useful, what you think is not useful, what is missing, what can be improved, etc., etc. So please let us know. In the next 2 weeks, Lars will be looking more in depth into the Marlowe language itself and the tools that you can use with it, but I would like to give a brief overview of the ecosystem now. There are currently 3 main tools. The oldest one is called Marlowe Playground, and it is an online tool that you can use from your browser, and it can be used for several things. First and most crucially, it can be used to create Marlowe contracts, and this can be done in a number of ways from within the Marlowe Playground itself. First, you can use the Marlowe language directly, and that's just text, so you can use the text editor that is built in the Marlowe Playground. But in addition to the functionalities that the text editors usually have, the Marlowe Playground text editor also has autocomplete functionalities that allow you to create a contract without almost writing any code. So you can use the mouse to choose which constructs to use where, and by the end you will pretty much have like the structure of the contract you want to do, and there's very little that needs to be typed. You can also use Blockly, which is a system that allows you to make contracts by dragging blocks like they were jigsaw puzzle pieces. And there is a more advanced technique of creating Marlowe contracts that takes advantage of existing general purpose programming languages. And with this technique, you can generate very large contracts easily by writing relatively small pieces of code. And the Marlowe Playground allows you to do this using existing languages Haskell and JavaScript, all from the browser without having to install anything. And Lars will look into these functionalities more in depth in week 4. The Marlowe Playground also has a few functionalities that help us ensure that the contracts we create do what we expect them to do. First, there is a linting mechanism, which basically automatically, as you are writing the contract, it will highlight the problems that it can find in the contract, obvious problems, and it will often make suggestions on how to fix those problems. And then there is the static analysis tools, and Marlowe Playground has 3 different static analysis tools. And it will check for working contracts that things like, for example, when you have a payment, there is enough money for making the payment, no matter which execution through the contract you do. Or, for example, whether there is pieces of code which are unreachable, because, for example, they are describing situations which cannot possibly happen. We will study this in more detail in week 6. Another way that we can make sure that the contracts do what we expect them to do is, of course, testing them. And the Marlowe Playground provides a simulator which gives you a kind of godlike perspective. So it allows you to move to the future in the simulations, so you don't have to wait for a timeout to occur in order to see what would happen if the timeout occurs. And it allows you to see the perspective of every participant. It allows you to control what every participant does, and it allows you to undo things, so you can try different scenarios and make sure that every scenario does what you expect it to do. Another of the tools in the ecosystem is MarloweRun, which allows you to actually deploy Marlowe contracts and participate in them. Until now, MarloweRun was just another simulator which allows you to take the perspective of the participants in the contract, but the latest version of MarloweRun allows you to actually deploy contracts and use them on-chain. Unfortunately, the latest version of MarloweRun is not yet stable. It only allows you to run 3 built-in contracts, not any contract, and it's still not able to handle a lot of people using it at the same time. So we are still figuring out what's the best way of sharing the latest version of MarloweRun with you. So it may not end up being just a website that you can connect to like Marlowe Playground is. We may end up having to have our local deployments of MarloweRun in order to use them. And lastly, MarloweCli is another tool similar to Cardano CLI, which also allows you to deploy contracts on chain and use them, but it is more fine-grained than MarloweRun. And on the one hand, that means that it is harder to use, but on the other hand, it means that it's more flexible, it gives you more control, and at the moment, it can also do things that MarloweRun cannot do, like running arbitrary Marlowe contracts that fit within the ledger rules. Brian will give an overview on the different ways to use MarloweCli on week 7. We will be making accessible a private testnet just for using in this program. And the testnet also has a faucet which can be used for obtaining test ADA in order to use the testnet. The testnet also has a copy of the Cardano Explorer that can be used to see the transactions that appear in the testnet. And there is also a custom version of Daedalus that can be used to create wallets and see your wallets in the testnet. And we will be using the testnet throughout the program, but the techniques we learn throughout the program will also be applicable, of course, to other nets like the public testnet or the mainnet. But at this point, we would strongly recommend against storing real funds in Marlowe contracts, because Marlowe hasn't been audited yet, and we are still working on making sure there are no vulnerabilities. Another particular consideration is that you shouldn't use a passphrase that you have used for a wallet that contains real ADA for a wallet in the private testnet. Always use a wallet that has been generated only for the private testnet and don't use it anywhere else. And that's all for this week. I hope you find the program interesting and that you have fun and you learn a lot with it. And again, we want to learn from you too. So please let us know your experience. Thank you for listening and see you on Tuesday on the Q&A session.